So dear students, we move on to another very important topic in electrostatics, and that topic is about electric field intensity and electric potential. So now we know that at a particular point in space, because of one charge or a number of charges, you can define electric field intensity and electric potential also. So these two are point properties of a point. Now the question is there any method of connecting the two, that is field and potential, and is there any relation between the two? So fortunately there is a relation between the two. So how do we reach that relation? So let me tell you that what I told you was work done by an external force in bringing it from a reference point to the given point is called the value of potential. So work done per unit charge is defined as the potential, and this work done is bringing it from reference point to a given point. So let us say if there is this point which I call as P, and the potential here is V is the potential. So this potential is nothing but work done by the external force in bringing it from the reference point to the given point slowly. That is, we don't bring it very fast, slowly. Now we know that like when we bring some charge from reference point to here slowly, so we can also say that work done by external force is negative of the work done by electrical force. So there are two forces. One is the electrical force, which is being exerted by the electric field which is there in space, and the other one is my force, the external force. So these two are equal and opposite, I can say, or better we can say they have opposite signs. So this potential you can also write therefore using this as negative of the work done by electrical force per unit charge. And this charge is a test charge. Now suppose I want to find the relation between electrical field intensity at point P, that is electric field intensity at point P, and the potential, electric potential. When I am saying potential, so be careful, it is electric potential, not gravitational potential. Now how will we go about this relation? So let us say suppose this is the origin, point 0, 0, and this is the position vector of this point R. So position vector simply gives you the position of that point P in that coordinate system. So let me not obstruct the writing here. Now suppose I displace it by some amount dr vector. So dr is the displacement, and let me remove the content on top so that you may not be confused about what it is. You can rewind and see anytime, like the video. So what happens is, like, this displacement basically is the displacement of, you can say, some charge. I am displacing some charge which is placed here by a distance dr. So there was some charge q which I displaced by a distance dr. Now let us calculate this, the work done by the electrical field. So let me again write, which I wrote earlier, that V is either you say work done by external or negative of the work done by electrical force per unit charge. So using this, we can say that work done by electrical force, work done is the dot product of force and displacement. So here if I am finding work done by electrical force, it is nothing, it is F dot dr. That is how you write in vectors. This is electrical force, this is displacement, and therefore V at this point equals to minus Fe dot dr dot product upon the charge q which I am displacing by a small amount. Now you also know that this force which is being exerted by the electric field. So don't be confused, like you may ask, like, which force is this? So this is the force exerted by the electric field which is existing in this space, right? So this electric field can be either due to a point charge or a number of charges, don't worry about that. But ultimately you can say that because we know that this electric field is also related to this force. Now electric field intensity you define as force per unit test charge. So therefore this force, this also I am writing here, you can write as Fe equals to Q into E vector. This is the electrical force. Electric field intensity is force per unit charge and force is charge into electric field. So we can write it as minus QE dot, so instead of force I am writing this equation here, and upon Q, so Q and Q cancels out and we should have written actually dV, because this when I am saying potential, it is the work done in bringing it from reference point to the given point, and if I am displacing it by a dr, this V is replaced by dV, the change in potential. So dV equals to minus E dot dr, and that is the relation between electric potential and electric field intensity. So be careful about this. This I wrote as the potential at a point when you bring from reference to here, and when you are displacing from, let us say, this point to this point, then the change in potential between these 2 points, that is dV, would be equal to the work done by the electrical force negative of that by Q, where I wrote Fe as QE. So QE dot dr by Q is only minus E dot dr. So pretty interesting relation, but you see it is quite mathematical. So now you have understood how we get dV equals to minus E dot dr. Now I will explain it to you what it means, so we can apply in problems when we are solving it. So you can again of course rewind and see if you are confused about anything. So I am again rewriting what I wrote just now, dV equals to minus E dot dr. नो आपको सबको फिजिक्स आती है, डॉट प्रोडक्ट आता है, इसको यू कैन ऑल्सो राइट एज माइनस ई इंटू डी आर इंटू कॉस थीटा. नो सपोज द इलेक्ट्रिक फील्ड इज लाइक दिस इन दिस एट दिस पॉइंट P, and then electric field at this point P is in this direction and I am displacing it in this direction, let us say. So dr is in this direction and E is in this direction. The angle between the two is theta. So you can see that like as you move from this point to this point, like let me call it as OP suppose. So O and P are very close points, so the distance between them is infinitesimally small, that is dr. So you can simply say that the potential difference between these 2 points, dV means potential difference between these 2 points, is nothing but negative of E dot dr or minus E dr cos theta. So if you look carefully, you can also write it like this, minus E cos theta into dr. और आपको पता है ये E cos theta क्या होता है, ये होता है component of electric field in this direction. E, इसके एक component आएगा E cos theta dr की डायरेक्शन में और दूसरा आएगा E sin theta perpendicular to dr. सो वेरी सिंपली अगर आपसे कोई पूछता है क्या रिलेशन है, तो आप कह सकते हैं दैट पोटेंशियल डिफरेंस बिटवीन 2 पॉइंट्स, potential difference between 2 points is equal to negative of the component of electric field in any direction multiplied with the small distance in that direction. So if you know the component of electric field in this direction, which is E cos theta, component of electric field in this direction, and multiply with that small distance, then you get the value of potential difference between those 2 points. Now to make it more simpler, let theta be 0, then we get dV equals to cos 0 is 1 minus E dr. So potential difference between any 2 points, if you are, now theta 0 means you are moving in the direction of electric field, so that makes it more simpler. So if electric field is in this direction and you are moving in the same direction, that is theta is 0, you can see here, then we don't have the component but the whole of the electric field along dr, and you can say that if you move from one point to another, then potential drop is equal to, potential drop or potential difference is simply minus EdR. Minus sign is important. So if you are moving in the direction of electric field, so you can see that dV would be negative. So you should remember that if you are moving in the direction of electric field and multiply with the distance that you are moving, then you get the reducing potential, decreasing potential. But if you are moving opposite to the direction of electric field, you are moving in the direction of increasing potential. So just if I make a statement that potential decreases in the direction of electric field. So if you are moving in the direction of electric field, you are moving in the direction of decreasing potential. So this equation, like general, this is general equation, minus E cos theta into dr, and this is a particular case of that, that is when we are moving in the direction of electric field. Now if you are moving in the direction of electric field, this can also be integrated. When we are writing E dot dr, if you integrate it both sides, this equation, then you will get it as minus E dr integration. So I am not using much mathematics here, but just remember that if you are integrating dV, then from one point to another if you are going, then you will get the potential difference between 2 points separated by large distance, and that will be minus E dot dr, minus E dr if we are moving in the direction of electric field, and in any other direction it will be minus E dot dr or minus E cos theta into dr. Another important point is, if theta is equal to 90 degree, then dV equals to 0, you can see, because cos 90 is 0. So it means dV means the change in potential, and theta 90 means perpendicular. If electric field is in this direction, then I am moving perpendicular to the electric field. So if you are moving at right angles to the electric field direction, if electric field vector is like this, you are moving in this direction, there is no change in potential. Maximum change in potential is when you are moving in the direction of electric field, and as you take some angle, for example theta, then change in potential in this direction would be little lesser than in this direction, and if you just make it 90 degree, there is no change in potential. So potential changes at the maximum rate in the direction of electric field and does not change at all perpendicular to the electric field. So these few things you should remember. Integration of electric field gives you the change in potential or the potential difference. Now since potential you get by integration of electric field intensity, so we can also say that differentiation, which is the reverse process of integration, differentiation of V gives you electric field. So आप यहाँ से भी देख सकते हो इसको, suppose इसी को मैं if I write it in differential form dV upon dr, so if I write dV upon dr, then I am left with minus of E cos theta. Now dV upon dr, देखिए अब हम उल्टी बात कर रहे हैं, पहले हम इलेक्ट्रिक फील्ड से पोटेंशियल पे पहुंच रहे थे इलेक्ट्रिक फील्ड को इंटीग्रेट करके, अब हम यहाँ पोटेंशियल को डिफरेंशिएट कर रहे हैं. तो मैं एक पर्टिकुलर डायरेक्शन में जा रहा हूँ dr, और अगर यहाँ पे पोटेंशियल मेरा चेंज होता है बाई dv, then dv by dr, that is the rate of change, this is what the rate of change of potential in any direction, that is equal to minus E cos theta, and E cos theta is what, the component of electric field in this direction. Once again E cos theta, as I said before, so minus dv by dr is E cos theta और dv by dr is minus E cos theta. तो इसको आप ऐसे भी लिख सकते हो, minus dv by dr equals to E cos theta. So just like I interpreted this, I said like if you multiply electric field with dr, that is displacement in the direction of electric field, then you get the change in potential, and if you integrate it, so you get the change in potential between 2 points separated by large distance. Similarly, we can say that dv by dr equals to minus E cos theta, and it will mean that this is basically, this term is called as potential gradient. So negative of potential gradient remember again, I am talking of electric potential, whether I write it or not. So negative of potential gradient, which is minus dV by dr, is equal to E cos theta, that is the component of electric field in the direction of dr. So equals to the component of electric field intensity. तो अगर आप इलेक्ट्रिक फील्ड आपको इंटेंसिटी दिया हुआ है एक पर्टिकुलर डायरेक्शन में, then you can integrate electric field multiplying with dr to get potential difference between 2 points. And suppose you know potential at some point, suppose potential is known at some point, then आप उसको क्या कर सकते हैं, you can differentiate potential with respect to r, differentiate potential with respect to r, and the negative of that would be the value of electric field in that particular direction. तो अगर किसी point पे you know potential and that potential is changing from point to point, suppose, see if the potential is constant, so dV by dr is 0, potential is constant, then dV by dr is 0, constant का differentiation is 0, so there is no electric field in that direction. But suppose you know that here the potential is something and after some time it is something, then you can find dV by dr, and minus dV by dr will be the electric field intensity in that direction. So you can see these two are quite closely related to each other, और इसको better हम समझेंगे when we do some problems. So you should also remember V, which is electric, is a scalar quantity and E is a vector quantity, but they are related by the basic definition dV equals to minus E dot dr. Dot product is a scalar product, so ultimately you get a scalar quantity. So E is a vector, dr is a vector, but the dot product is a scalar quantity. So this scalar quantity at a point is connected to a vector quantity at the same point. So if you know the potential and the rate of change of potential, you can find electric field intensity. If you know electric field intensity, then you can integrate it to get potential difference. So from electric field you can find potential difference, and from potential by differentiating you can get electric field. Differentiation of potential in simple words gives you electric field. Integration of electric field intensity or electric field simply gives you the potential difference. So in this video I just wanted to explain you this small but important concept, and we have covered a lot of theory of electrostatics. The remaining topics are Gauss law, you just wait to see what is Gauss law, and then what is the meaning of electric dipole, and then gradually we'll also start moving into problems like of electrostatics and even the other topics. So I'll soon be launching those videos also. Thank you.